Hi, I want to give you a little intro on putting together some of the work you've done before the quarterly and that we're continuing to do with balancing. So as you read this word equation, you're going to write the formula equation. So it says magnesium reacts with an aqueous solution of hydrochloric acid, which is HCl. So that means that magnesium, which is Mg, and it's not diatomic, so we don't need a 2, reacts with is our plus sign, an aqueous solution of hydrochloric acid. So the formula for hydrochloric acid is given, it's HCl. And then it says to form. So that implies our arrow or our yield sign. And what we're forming is an aqueous solution of magnesium chloride. So magnesium chloride, you're going to have to get your blue packet out. Right? And you'll look up magnesium on the periodic table to see that it has a 2+ charge, and you'll look up the chloride ion on the periodic table to see that it has a -1. So if you cross it down, you're going to get the formula of MgCl2. Okay? And bubbles of hydrogen. So plus H. But remember, hydrogen is diatomic, so it's going to be H2. Okay? So we've written the formula equation. The next thing we have to do is include states of matter in parentheses. So let's read back through the problem again. It just says magnesium reacts with an aqueous solution of hydrochloric acid. So after our HCl, we can put AQ, meaning it's dissolved in water. Now, think about magnesium. It's a metal. The only metal that's liquid at room temperature, which you can kind of assume is happening, would be mercury. So magnesium is not mercury. So we can pretty assuredly say magnesium is going to be a solid. And we put a little S there. Okay, so then it says to form an aqueous solution of magnesium chloride. So this is going to get AQ. And then bubbles of hydrogen. So bubbles of hydrogen are going to mean a gas, a gaseous state. So H2 is going to get a little G. So at this stage, we have done the green highlight. Next, we have to balance the formula equation. So this is kind of the new piece of information. So I'll just put my marks here on where I'm allowed to put a coefficient if we need it. And then we'd say, okay, Mg is one of our elements, then H, then Cl. And I'm just going to make my little chart here. And then I'm going to count. I got 1 Mg, 1 H, 1 Cl to start on my reactant side, 1 Mg, 2 H's, 2 Cl's to start on my product side. So it looks like the only thing that doesn't match up are the H's and the Cl's. We have 2 over here and only 1 over here. Oh, look, we can fix that because HCl are together. So let's just throw a coefficient of 2 in front of the HCl. That's going to change the H to 2. It's going to change the Cl to 2. And look, now all 3 of these match, and we can say we have a balanced equation. Lastly, we are going to write whether or not the reaction is endothermic or exothermic for any starred equation. And you can see we have a starred equation here. So there's enough information to tell you whether it's endo or exothermic. Remember, endothermic means heat is absorbed. Heat absorbed. And then exo means heat is released. So in our example here, it says, as the reaction occurs, the test tube becomes hot. So that would mean that heat is being released, and we would say this is an exothermic reaction. One quick thing I want to remind you about is Dr. Janine Honkelbreff. Now, this is just the mnemonic device for remembering the diatomic elements, the elements that occur in nature in pairs. Okay, so you're never, if it says hydrogen, you're not going to write H, you're going to write H2. If it says bromine, you're not going to write Br, you're going to write Br2. For any of these elements, okay, it always occurs in pairs. So if you forget about that when you're doing these translations of word equations to formula equations, you're going to get yourself messed up and it's going to be harder to balance. So just make sure that you're paying attention to diatomic elements.